Hello.
So yeah, I can hear you. So
Yes, I can hear you.
yeah, I can hear you clearly.
Yes, sir.
So we will be studying about the backward and forward sweep. Backward and forward sweep. So what does this backward and forward sweep indicate? Suppose you are having a transmission line, okay, at this point one, node one, it's starting. The basic point would be the slack bus. Slack bus is the bus where you only know the quantities of voltage. Okay, that is the voltage magnitude, and you have the phase angle, there at the slack bus.
Yes,
And
sir.
you are moving in another bus is getting connected. Suppose here a current I between this, you have a current I12, right? This current is getting absorbed in this bus, okay, as S2, you can see over here. Then there is one more line. This is a transmission line, okay, which you are saying this is a transmission line. This is a transmission line, okay, and you are having a bus three where you can see another bus three is going. So between this I12 is flowing, and here at S2 current I2 is going down. I2 it is getting divided at this point into I2, and between this point it is getting divided into I23. Now you notice after that it's going nowhere. So I23 is only going, and I23 will only come out. So this I23 will only come out. If you name at bus 3 the current to be as I3, then I3 would be nothing but it would be equal to I23 only, right? This would be the same quantity here. So uh, in forward and backward sweep, what happens is that for the current calculations, we do the backward sweep. For the voltage calculations, we go for the forward sweep. So the first steps, I'll write some steps. You're like I read that book night, your thing, it's very confusing.
Yes, sir.
Step number one is you calculate the current at each node. Calculate the current of each load. So this calculation of the current of the each load would be given as at any node would be given as Sn Vn conjugate. That Sn would be power at that node. Suppose at this point P12, what is the power? Yesterday we have shown this Sn value is nothing but equal to P plus JQ, right? Okay,
Yes,
suppose
sir.
S12 value in the Gauss seidel I've shown you P12 plus you can say JQI2, right? And what would be
Yes, sir.
S12 conjugate equal to S12 conjugate? Only the sign will change here. That is P12 minus JQI2. This sign will change over here, right? You got my point. So when you calculate the current in the line, okay, so this Sn value would be equal to P plus JQ, whereas Sn conjugate would be equal to P minus JQ. I have to check whether, see, in your that, okay. Now the step number two is that when you are calculating the current, calculation of, when calculation of current is needed, current is done, that time consider, consider current from the terminal point. From the terminal would mean the node, last node, terminal last node. So here the terminal point would be this. Okay, instead of going in this direction, what we do is in this, we consider the current like we don't consider it in a forward mode. We consider the current in the backward mode. So this
Okay.
is, yeah, we consider when we are going in this particular direction, we will consider the current in the backward. Yeah, here it is. This text will go up. Yeah. So how do we go about this is we will say that okay, by this is I23, this is I23 is like this. Okay. This I23 is
Yeah.
on this I23 is only going here. And this is the point. Okay. And this is how it is measured. So in order to get this value of this node, you see this current is only getting divided here and here. Okay, so this current. So calculation of first step is to calculate the current of each line. That is, you have to start from the end of the feeder. Okay,
Okay.
so this is feeder one. Okay, this is
Yes, sir.
feeder two there, and this is the feeder three. So you have to for backward sweep for backward sweep current calculation current calculation needs to be done needs to be done from the end of the feeder. Okay. And now at IN you have calculated. So IN here would be current at this node. Okay, this would be IN, suppose. And at this feeder would be the last C. After IN, what you are getting, other value, the immediate line would be, okay, you get different values here. Okay, and this summation here, this and this value. So you can write one formula. Okay, I'll give you this formula. It's not there mentioned in your this formula you can write to calculate this I n minus one line. Okay, that is your basically your this line would be equal to IN. Okay, that is your IN. This IN, this line I3 line. You have to calculate the I3 line would be equal to your I1 line plus the summation of the currents in the other lines. Okay, plus the summation of IK line. Okay, here you see this is your I3. So this is your I1. Okay, this is your I1. And this I3 is equal to basically the summation. This I3 and I23 are the same only. So this is only I3 would be getting divided into I2 part only. Okay, so there is not a big difference. So this is called as backwardly you will calculate the current.
Okay.
Apply KCL in the backward direction, not in the forward. Apply KCL in backward
Backward direction.
backward direction. That's why it is. That's why you're seeing there now he's written like this. I3 is equal to I23, right? Uh,
Yes, sir.
why he has written? Because see, first of all, when to search the currents, then you have to apply it in forward. Okay. Then you have to apply it in backwardly. Then he has written also there. If you look at that, he has also written there the same thing. I12. Okay, here if you see I12 would be equal to, technically speaking, I12 would be equal to I2 plus I23. Okay. But now I
Okay.
will show but we don't have to take like this. Now, can I can I go to the next slide?
Sir, 1 second, sir.
Uh,
Just jotting it down.
hmm, tell me the doubt.
No, sir, I'm just jotting it down, sir. Writing it down.
Jotting it down. Okay, I thought doubt. Jotting I heard as doubt.
No, sir.
Okay. Yeah. Yeah, I'll also save this as a PDF.
Yes, sir. Yes, sir. Yes, sir.
Yeah, it will be beneficial for you. Then I can send it to you. With the example, you will understand it more. We'll solve this example also.
Yes, sir. I'm a little hazy as to what
Yeah,
We've
with the
done, so I think.
yeah, you remember these steps when I show you in the example, you'll understand it in a much better way. Okay.
Okay,
With the
sir.
when I put the values now, I'll explain you. That time, don't worry about
Yes,
it.
sir, yes, sir.
Okay, this is little
So,
looking.
the fourth step is at I n minus one, this thing.
No. This is the first step. Is that first step is you have to calculate this value, in value. Okay.
Yeah, correct.
Okay, this is the first step. Then
Yeah,
then in the second step, what you have to do is that you have to calculate the value of this by looking at backwardly. In minus one line current you have to calculate in this direction. Okay, like this you have to calculate like this in this direction. Backwardly you will see. When
yeah.
calculation of current, that time consider current from the terminal node, last point. Okay. In the first step, you calculate the current here itself. In would be
Yes,
this
sir.
value. In would be this value.
Correct. Yeah, correct.
In the second step, you have to do it backwardly in a
Okay.
backward motion, and this backward current would be equal to, see, this backward current would be equal to this current in plus this current,
Yeah,
right? So this
yeah.
backward current would be equal. If there were many nodes, usually not more than three buses will come in the examination. Okay, so
Okay, sir.
this is equal to k is equal to n, and your ik line. Okay, the summation of this. So once this process of calculation of line in the reverse direction, this process is called as backward sweep. That's it. In this step only it ends. This is only backward sweep. Okay.
Okay.
Now can I move to the forward sweep? So backward.
Yes, sir, yes, sir.
So remember one thing. In the backward sweep, what you have to do? First, you have to calculate the current normally. Like normally, you have to write the like you have to calculate the whatever would be the SIN, whatever would be the reactive power here, S12. Okay, there would be some power that
Yeah.
we mentioned. That power you have to divide by this current IN.
Okay.
Once you get the value of IN here, okay, you got the value of IN. So this IN is done. Okay, but when you are writing for this current, you should not write from here. You should write from here backwardly. So if you write from
Okay.
here also, if you look at this current also, this current from forward direction also, it is getting divided into, it is going here and it is getting absorbed in this part and it is going here. Okay. But
Yeah.
if you take it from here, I23 going here, it is getting absorbed here. Okay. And some portion is coming here also, just to do the reversal of the current. Suppose I3, I say that from my this direction only the current is moving. Okay, just this is my input and this is my output. That is why it is called backwardly. Just time
Okay.
reversal of the just phase reversal of the current. Okay. Huh?
Okay.
So you apply the
Yes, sir.
KCL from the last node in the reverse direction. But
Okay.
while calculating the first value of IN, you have to calculate in a forward direction only. You have to directly write Sn divided by Vn. That's it. These 2 points are
Okay.
backward sweep. It is done. Okay. And now let me tell you about the forward, because there's too much confusion that your teacher has given there. Okay.
Yes, sir.
Even I got confused. Like I just went through it. It was very much confusing. Others are understanding, huh? Other students
No, sir. It was very here.
here and there is given here. You are like whenever I've explained you this current transformer. Sorry, in the last part I got myself. I was tired. I was done.
Yes, sir.
So I was
Yes,
like,
sir.
I was myself, but the main thing is not the calculation part. That trigonometric identity also, what I rewrote is was wrong. I just saw in the last part, na. So it was done there
Yes, sir.
only. I just got confused whether it is degrees or radians. Then you told me, sir, it's in radians. Okay,
Yeah.
because I was not having that thing. I had written in the paper, na. I did not had to.
Yes, sir. Yes, sir.
I was just opening in my mobile. Then I opened my mobile. He had only written that trigonometric identity. Then something he will write, something down he will write wrongly. See, if you look at it whether it is wrong or not,
Yes,
huh?
sir.
The actual thing is there
Wrong, sir.
itself. There itself it is getting over. The problem is there itself getting over. Okay.
Yes, sir.
Okay. Then now can I move to the next slide?
Yes, sir. Yes, sir.
Yeah. Now I'm moving to the next slide. Now when now this see why it is called as backward and forward. This is called backward, okay, because KCL gets applied in backward motion. Okay, motion KCL is getting applied in backward motion. First, again I'll write the first step is to calculate current
Current from each node.
current. The first step is to calculate the value of current from the in forward direction only. It is in forward. So the forward direction current is given as SN VN conjugate. One more important thing there in that problem, what I've seen is it has written in terms of P plus JQ. It cannot be in P plus JQ. If SN value is P plus JQ, SN conjugate would be P minus JQ, right?
Yeah.
The conjugate would be P minus JQ, not P plus JQ. That thing also you have to keep into consideration. Okay. Okay. Yeah, but again, then the Vn conjugate, if Vn is equal to 1 at an angle of 0 degrees, Vn conjugate would become what? 1 at an angle of minus 0 degree, which is the same thing. Is it the same thing? 1 at an angle of 0 degrees and minus 0 degrees, is it the same
Yes,
thing?
sir.
Yes,
Same
it is.
thing, yeah.
Why it is the same thing? Because 1 at an angle of 0 degree is basically cos 0 degree plus j sine 0 degree. Here it would be cos minus 0 is again 0 degree minus j sine
Zero.
0 degree. So this is only coming as 1. Okay, so whether it is minus or plus, it won't matter. Okay, now remember one important thing when we are going for the calculation of the voltage. So we will calculate the voltage at each bus starting from the first bus. So starting from
The first,
first bus. So the first bus. So this thing, the KVL gets applied in forward direction here. Sorry, KVL gets applied in forward direction. So this is called as forward sweep. Okay. So suppose you had that line over here. This was your line. This was your second line. And this is 1 and 2. And some impedance between this line is x12 or sorry, z value is this 1, 2. Or you can convert the z into y12 also, if for your convenience, whichever is easy for you. Okay, it can be anything can be given over there. And this your
yes, sir.
third line. Between them, it can be in terms of y23 or it can be in terms of z23. Okay, and then
Okay.
this is your power s3 here. There is your power s2, right? Okay, now
Yes, sir.
now what you have to do is that you have to calculate the voltage, the loss in the voltage. So the loss in the voltage would be Vn minus the line that you are seeing, Zn line, okay, into In line. So this is your first bus. This is a slack bus, which will take one at an angle of 0 degree. Usually the first bus is taken as 1 per unit. This is it.
Okay.
This is it. This is it. Only these many steps are there. No more step is there. Now let me solve the problem. Take it down, and I'll solve the problem in 2 minutes for you.
Yes, sir. 1 second, sir.
Hmm?
Just writing it down, sir.
Huh?
Just writing this last part down, sir.
Which last part?
No, no, I'm just writing this down, sir. 1 second.
Yeah, no issue. You write it down. No problem. These these many steps are there only. Okay. First step is
Got it.
that, second and third, only this. This is forward and backward sweep. No more than this.
Got it, sir.
Okay.
Yeah, yes, sir. 1 second.
Hmm. Shall we solve this? Okay, you will take it down. No issue.
Plus Zn line into In line, right?
Yeah, IN line. I'll save it for you. No issue. I'll save it for you.
Yes, sir. Done, sir.
Okay. Now, on the same grounds, this thing he has mentioned here, the first bus is the slack bus. Okay, if you look at the problem wherein he's mentioning the values, okay, wherein he's writing the S2 value is equal to, if you look at your problem, okay,
Yes,
S2 value is equal to 1500 plus J 750 kVA, right?
yes,
Yeah, so this is 1500 plus 750 kVA. So this can be written in terms of VA also. 1500 plus J 750 K term can be written as 1000. Okay, and this term is into VA, right? Similarly, your another term, you have that problem with you, no?
yes, sir. I'm opening
Yeah,
it now.
just open. I'll wait. Just open because unnecessary. I don't want to waste the time in writing the problem and all that because we have to cover a lot of things.
Yes, sir.
Opened it,
1 second, sir.
no issue.
Sir, I can't find the problem, sir.
Hmm? Okay,
Can't find the problem.
okay, no issue. I'll just write down it. Okay, so this is a transmission line. Okay, wherein your S2 value he has given is equal to this, and S3 value is mentioning is equal to 900 plus J into 500 kVA. This is the problem he is there. It's come in your examination also in one of the papers. Okay. Now he mentioned this line. This is a basically a transmission line, and this line is having a length of 3000 feet. Okay. And
Yes,
then
sir.
there is another line L2 which is having a length of 4000 feet. Okay. So one thing you remember, your 1 mile is equal to 4 to 5280 feet. Mile to feet conversion. Okay. This now S1, sorry, what is the term there? S2 and S3 terms are given there. Okay. Wherein
Yes, sir.
this bus, the first bus is the slack bus. Okay. This is
Okay.
the slack bus. In slack bus, we we usually start the slack bus. From there only we take it as a reference. Wherein wherever we will have S2 term, S2 would mean load bus. Why? How it will mean load bus? Because it is having P and Q terms. Okay. So it is basically
Yes,
a
sir.
PQ bus, but here it's a slack bus. And the voltage there, he's mentioning the voltage of that bus. It is starting voltage is 700,200 volts. The voltage here is not 1 at an angle 0, but is 7200 volts. Okay, this is its starting voltage there at the at an angle of 0 degrees. Now 1 mile is equal to 5280 feet. You know that.
Yes, sir.
And one more thing he's mentioning is that your Z12, the impedance of the line here, he's telling the impedance of the line, the Z12 value is equal to zero point 0.3 plus J 0.6. Okay.
Yeah.
Similarly, Z23 is also equal to zero point 0.3 plus J 0.6. And the unit of this is very important. Okay, this is unit is in terms of ohms per mile. Okay, so but our unit should be in terms of ohms per feet because the length of the transmission line. So the total impedance of Z12, total impedance, see, would be for the entire length of the line. So at a point, the impedance is equal to this value. But what about the total length? That we have to take into consideration. Now Z12 between 1 and 2 it is connecting. So it is 3000 feet. Okay, this is 3000 feet. What we need to do is we need to multiply this 0.3 plus j 0.6 with 3000. Okay, it is in feet. We need to convert if feet into miles. So 1 feet would see so if we need to convert this, so 1 feet would be equal to 1 divided by 5280 miles, right? 1
Yes,
feet.
sir.
So here I have
Yeah, yeah, correct.
so I have to convert this. So here I will convert this and I'll divide it by 1 by 5280. So I have converted this. So this will give me the value of the Z12 value would be given here. I'll write with a different color here so that my Z12 value is given. So my Z12 value would be given as 0.3 plus j 0.6 into 3000 divided by 5280. Similarly, Z23 would be same because the value is same, so it would be again. Whether it would be same or different, Z23, tell me. There would be some
Same.
different. No, how come? What is the length of Z23? What is the length here?
Okay.
What is the length?
Why 400,
No, no, what is the length?
400,
No, no, this length is how much? 4000. This is
4,000, sorry.
this is 4000 feet. This length was 3000 feet, right?
So change it,
So this will change because of this. This numeric digit will change. So it would be 0.3 plus j 0.6 into 4000 divided by 5280. Can you calculate it and tell me the value? In rectangular form only, can you calculate and tell me the value for Z12 and Z23?
Z23 is 0.2272 plus.
Hmm.
Yeah.
Simple, yeah.
So, like that.
Yeah, tell me.
Uh,
Yeah, tell me.
so for Z23, that is
Uh,
0.2272 plus J 0.6.
yeah, how much? How much did you tell? Point two two.
So 0.2272
Yeah, plus
plus J 0.6.
plus j 0.6. Okay. Whatever the value. Okay. So you note down that value in the calculation. But can I move to the next session? Next slide.
1 second.
Next slide.
1 second. 1 second.
Hmm. Hmm. Delete down this. Okay. This thing is down here.
Yes, sir.
I'll move to the next. I'll save this first. Save PDF. Okay. Okay. Now I saw that ki bhai, okay, it is done. Now I have to apply. I have to calculate the current. Okay. So in order to calculate this current, so this is my S2 point. Where I have to start? I have to start at because here there is Vn, but there is nothing
Yeah.
P or there's nothing is there. So where I will start? I will start at this point S3. Okay. And to calculate the value of In, what was the value of S3? In would be equal to S3. What I told you, In would be equal to Sn divided by Vn, right? So here
Yes, sir.
your Sn would be S3 divided by Vn. So S3
Yeah.
value is given as P plus JQ. S3 value was given as 900, okay,
Yes, sir.
plus J, how much? 500, right? But here
Yes, sir.
you just look at this, it is given as a conjugate, right? The term is in conjugate. So your S3 conjugate will become equal to 900 minus J 500. And this value was given in terms of kVA, right?
Yeah.
So what we will do is that we'll write this equation for In here. The value of In would be equal to 900 plus J 500 into 1000 volt amps divided by Vn. Vn is 7200. The first step of In is done. Okay,
Yeah.
In we have
Yeah.
calculated. If you calculate it, if you this plus will become minus. Keep, yeah, because it is conjugate. This will be
Okay.
because it is S. See, I told you na, this would be S3 conjugate. This is S3 conjugate. So this plus term will become minus. So this would be basically 900 minus J500
Okay.
divided by 7200 into 1000. Can you calculate this value and tell me the answer? Kindly calculate this. You, whenever you are studying with me na, you please, my
Yes, sir.
calculator yesterday got like damaged. It was in the bag. Otherwise, I would have calculated myself. I want to see, because if you make some calculation error, then what is the fun of me teaching?
Yes, sir.
Tell me. Don't do like that. Okay, put in the calculator. I don't want like this. You should not do like this. 900 square plus 500 square, then
No, sir.
tan inverse of 500 by 900. This is also one form. This will give the magnitude. This will give the angle. Okay.
Sir,
Directly, to
wait, sir.
rectangle,
What?
rectangular polar conversions, right? Rectangular to polar form conversion,
Okay, 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 okay.
yeah.
So, okay, you convert that. Okay, okay.
Convert, yeah, or yeah, convert that. Now in the calculators directly also you can write in rectangular and you can get the value in polar. Okay,
Yeah.
do that. Write this in the rectangular form and convert. If you are not knowing this, now see some video on YouTube how to do. Because different calculators have different procedures. I don't know which calculator you are using. In two
Yes, sir.
minutes, yeah, these things, these tricks you should know. Okay,
Got it, sir.
yeah, calculate it.
Yes, sir.
See, on similar grounds, see S3 dash, you should be able to do it. Okay.
Yeah.
So once you have calculated this value, na, then your I23, basically you have now what you have calculated this. This is your value of I3 you have calculated. Now what I told, backward sweep from this direction. So this
Yeah.
I3 is basically the current that is flowing. This I3 will be equal to I23 only, right? In the forward sweep, I've shown you this. Okay. That's why they use for the forward sweep. In the forward sweep, I've shown you now this value I1, then this is
Yes,
I
sir.
I2, then this I23 is equal to I3. So this I23 is nothing but I3. This is the same value here, right?
Yeah.
I23 is equal to I3. But what about this I2? Now we have to calculate I2. In order to calculate I2, again, what we have to do is we have to go for S2 by Vn conjugate. Okay. Now, for some odd reason in your solution, what your sir has given, he has written 900 plus J500 instead of minus here. That I did not get. It should be
Oh,
minus.
yes,
In
sir.
you in your module, he has written plus.
Yeah.
It should be
Oh,
minus. You are getting my point.
Yes, I've heard.
I did not had the calculator, so I could have verified the solution. I would download it, get calculator, na? Okay,
Yes, sir.
so I will do it. So I don't know whether his values are correct or not. Okay, so values you need to calculate. Okay, when we are sitting for the tomorrow's class now, therein we will see. I will just, because tomorrow is Monday, I have
Yes,
one calculator in my college. Here my calculator it broke actually.
right.
Yeah, yeah, unfortunately. So I was just checking this. Okay, here S2 by Bn. So what is the value of S2? S2 value here I had mentioned in the previous slide also. You see the S2 value is 1500 plus J 750.
Yes, 750.
So yeah, so it would be S2 would be 1500 minus J 750 because of the conjugate. This minus
Yeah.
sign is coming because of the conjugate.
Got it.
Divided by 7200. And there is 1000 term because of the reason of KVA.
KVA.
So this we have to express this in terms of VA. Why we have to express this in
VA.
terms of VA? I will tell you why we have to express. Because if you look at the transmission line, it's expressed in terms of ohms. Okay.
Yeah.
If the impedance is expressed in terms of ohms, then voltage should be expressed in terms of volts. Then
Volts.
current should be expressed in terms of amps. Okay. The dimensional analysis should be the same when, because we
Yes,
have to
got it.
calculate the, for that reason we are expressing in terms of VA. Okay, so you have expressed this I2 also. Now once you have calculated this I2, now you look at this thing over here in the backward sweep. The backward sweep says that this I23 is like this, I23 like this going down and going here, and this is equal to your I12. So you can write your I12 value. I12 value is equal to I23 plus I2, right? So I23 plus I2, where your I23 is nothing but as I3 only, okay? I have already shown you I23 is nothing but
Yes,
as,
sir.
here you note,
Yes,
I23
sir.
is nothing but as I3 only. So from here you get I12 value, right? So the value would be the calculation of this part that you have to do. Then calculation of the which part was there?
So,
This,
I3,
uh,
then I2.
I2 and the
The
I3.
right side part and
That part. Okay, so you do that. Now, final step is for the backward sweep. For the backward sweep, what you do is that you have this voltage here V2 and voltage here V3, right? And this is a slack bus wherein you will give one at an angle of 0 degrees, but here they have not expressed in terms of per unit. Here they have given this voltage of the slack bus to be 7200 at an angle of 0 degrees. So in order to get this voltage, so you go for a forward sweep. What to do is that you write the value of V2, basically this voltage V2 that you are getting here would be equal to this voltage V1 minus the drop in this line minus I12 into Z2, right? Yeah, this voltage V2, whatever the voltage, suppose this is my house 1, okay?
yeah, yeah,
This is my house 2. Now at house 1, I have some voltage V. Suppose my house 1, I have
yeah.
7
So,
to,
one second, sir.
mm,
So the time is about to get over.
yeah.
Yeah.
So,
Okay, can you save it, sir?
yeah, I'll save it for you. Okay, I've done it. Tomorrow I will explain you. Okay, this is your
Yes,
house
sir.
1, this is your house 2. In between, there is an impedance in the line Z12. Okay, so this
Yes, sir.
7200 and there is current also. What value of voltage would reach here? That would be 7200 minus I into Z12 would be reaching the house 2. That would be the voltage, V2 would be the voltage at house